Good morning, friends. Happy Tuesday. So, what I'd like you to be doing is looking in the background and seeing some of the things that I've pulled out to create my bridge. Don't build anything today. Just prepare your ideas and collect your materials. When you're thinking about your bridge today, think about what you learned about yesterday in the different forms of different bridges that are available to you, like beam bridges, truss bridges, arch bridges, and suspension bridges. Now, some of these things we actually can't build in our houses because of the materials that we have. But truly, this project is up to you and your imagination. Don't let your lack of materials stunt your ability to develop something pretty neat and cool. So if you don't have Legos, it's not a problem. You can use a lot of different materials around your household. So again, look at what's behind me. You're going to need to think about things for weight. That's what's up on top of the table. You're going to have to think about things that might be recyclables. You might pull out things that will be used as the bridge material that will support the entire structure. Okay, so I have a few different videos for you to watch. You're going to watch those videos, and then you're going to make sure that when we come back together, that all that you're doing today is collecting your materials and thinking about your design. So you're not building anything, but you're writing down what it is that you plan to use and what it is that you might be accomplishing in that task. Thank you. Watch these two videos and then check in with me at the end.
At the core of the Roman Empire was their engineering prowess, and most notable of all their infrastructure advances was the Roman arch. The arch bridge and arched structures allowed the Romans to construct buildings with a far greater ratio of wall openings to height than had ever been possible before. The evidence of such architecture is found not only in the Roman Colosseum, but also the labyrinth of arched catacombs that lie beneath historic Rome. Focusing in on the arch bridge, it was a technology never seen before, one that allowed boats to pass under walkways and roads, and one that enabled the Romans' famous series of raised aqueducts. But ultimately, why was the arched bridge so crucial to the Roman Empire, and what structural properties of the arch have enabled Roman architecture to survive relatively intact even to modern times? An arch bridge was, and is, so revolutionary to structural design because the elements of which function almost entirely in compression. Due to the distribution of both dead and live loads on the arches, stresses are always translated into compression, allowing for materials such as rock or unreinforced concrete to be used effectively. If you know anything about concrete's and rock's material strength, you likely know that neither function practically in tension loading. Nowadays, concrete beams are reinforced with rebar to allow for tension loading, but the Romans didn't have that ability. As an arch's radius of curvature increases, it begins to behave slightly more like a beam. Therefore, low compression forces, or tension forces, begin to appear on the underside of the arch. The Pantheon, still the biggest unreinforced concrete dome structure in existence, is estimated to have also been the largest domed structure that the Romans could have built without collapse. Examining how much load an arched bridge can hold is a little tricky. Since all of the components of an arch function in compression loading, the maximum values of any given arch are essentially equivalent to the shearing point of any material. Granite, for example, would be a far better arch construction material than sandstone. Even still, the ability for arches to hold load is far beyond any other structural element, even those today. A well-built arch from stone doesn't even need mortar to connect the parts. Rather, the friction forces from compression keep the structure stable. Rather than spend hours determining the maximum load of an arch constructed of a given stone, we're going to settle with a maximum loading value of a really big number. For the Romans, and even engineers today, a solid arch structure's yield point is far beyond realistic loads that a structure would ever see. These same principles that made the arch so strong also made them last so long. When a structure created from arches undergoes a series of loads creating low material stresses and strains, fatigue seen in the arch over time is very minimal, if anything. Since arches' yield points are so far beyond practical loading values, they tend to last until the rock or structure is weathered, in turn, a very long time. The Romans did use concrete to build many of their structures, like the Colosseum. The concrete was far more resistant to weathering than modern concrete due to the abundance of volcanic ash used in its construction. Through this increased weathering capabilities and the strength of solid arches, Roman architecture and buildings are still around today in nearly all of their original beauty.
So I wanted to find a video that would detail the Roman arch and how valuable that simple structure was, even in today's structures that we use. So the arch is a really great structure. Now, you might not be able to make that, but if you want to spend the time to try to stack something in that will support itself and create some type of structure that would hold weight, I would be very impressed. All right, guys, I just want to go through some of the materials. You're not going to make a video, but you could take a picture of what you're putting together for your bridge materials, and then what you could do is share your ideas for what you might do with your building. So for instance, it might be something, like I said, that you're taking a picture of, but I'm going to go through some of my ideas that might spark some of your interest for your own design. So I took some boxes of macaroni and I taped it together. You might need to do some taping to build your structure. So I'm just making that something that's sturdy so that, let me move my coffee. If I want to build something and use this as my overall structure that's going to be on top, you can see that that's not going to hold any weight, so that I might need to use, oh, you're laying down? Okay. So I might need to use some type of different structure underneath to add some type of stability or rigidity across the top of my bridge. Now, if you don't have something that long, then that's fine. Maybe you want to use a book. But remember, if you're using a book that's solid like this, it's going to be a bit easier for you to share the structure of your bridge. I'd like you to find something that's like a bit longer and doesn't carry as much weight load. So see here, this is very flimsy, flexible. If I use this structure and try to put any weight on top, oh, I didn't think that would work. Any weight on top, it's not going to work. So it causes me to do more with my engineering. So I might want to think about some of my recycling. Yes, I like Pringles. So here, you might be using things as structure for your bridge, or different cans or things that you've already recycled. You could take out your Legos and build something with Legos. Whatever it is that you want to do, you're building a bridge. And so I want you to have the day to think about it and start your construction. Don't post anything, just share your materials, either through a picture or a list of something that you've typed out to tell me what you're using. Thank you for watching today. Tune in tomorrow, and we're going to learn a little bit more about bridges, and I'd love to see what you're designing. Not today, just your list, but tomorrow we'll do our building. Have a great day, guys.